Okay, good morning, for science 1 and for science 3. Very good morning. This is our first lesson of today, 8:30. And I want to say thank you and congratulate those who wake up so early today. Okay, very good. You can wake up, you can make it even though 8:30 we start our lesson. And also this is our physics last lesson already. Okay. So after finish this, so no more physics lesson for 1 month. Okay, you go for your holiday, 1 month holiday now. Okay, so for this morning, I would like to discuss the last set of paper, set number 5. Okay, I hope you have the paper ready with you now, set 5. If you haven't printed out, never mind, you just refer here. But at least you must have a piece of foolscap paper to write out the answer. Okay, so I share the paper with you now. This paper now, okay? Can see or not? Can you all see the paper? Can see the screen?
And
Okay, thank you. First question I want to ask by looking at this question, can you tell me this is under which topic? You know or not? This question is under which topic? Which topic you have learned one? Under which topic? Sid Ailing? Can you come up, please? Answer this question. This topic is under which topic? This question.
Chapter 5.
Yes, chapter 5. What is the name of the topic? Remember or not? What is the name of the topic? One word, Sunny.
Diffraction.
Diffraction. Diffraction is not a topic, it's a sub-topic. Okay, Tae Yiling, what about you? Do you know the topic of this chapter, this question? Tae Yiling, Bing Hao, you know or not? What is the name of this topic?
wave.
Wave. You study wave, okay? You study water wave, sound wave, light wave, electromagnetic wave, all this, right? And also you study reflection, refraction, diffraction, and one more is interference. There's so many things and all. Okay, come look at question number 1 now. Okay. Diagram A and B show two sets of ripple tank used to study diffraction. Now is given already. This one is for diffraction. Okay. The first diagram show that this gap is so big. The gap larger than the wavelength. You see the lambda? Lambda is here. But the gap is bigger than the lambda. So what will happen? Second diagram, you see lambda is still the same, but the gap now becomes smaller. Okay, this is very obvious, you know that. For diffraction, right? When the gap is bigger than the lambda, the diffraction will not be strong, will not be obvious one. So most probably the wave is just like that only. Bend a little bit, diffracted a little bit, okay? Just like that. Okay, diffracted a little bit. Whereas this one now, because the gap is small, so this diffraction will be very strong, very clear. So it's like that, it's curved shape. Now, you see the diffraction different. Okay, this one will be diffracted like that. This diffraction is stronger. This diffraction is weaker. The reason is that when the gap is bigger than a lambda, so diffraction is not obvious. Whereas in the second diagram, the gap smaller than the lambda. You see, gap smaller than the wavelength, right? So diffraction is very strong. Strong means the shape will become a curved shape. You can see here the direction of the wave is moved this way. Okay, so it's spread out like that. Okay, spread out. Bigger angle line spread out. whether this one spread out smaller angle, is spread out also, but the angle of splitting is smaller lah. The angle smaller, this one angle bigger. Okay? Understand now, everyone? King Sing Yu, do you understand? King understand or not?
Yes, sir.
Okay. Redraw and complete the diagram to show the difference between two. This one, everyone, please draw properly. When you draw now, okay, class, make sure the wavelength after before must be the same one, you know. The wavelength never change one. Okay, please draw it properly so that the lambda wavelength remains the same. Okay, here lambda and the lambda here must remain the same. Okay, do it now, everyone. Take down the answer. So very obvious, I remember under diffraction, right? Wavelength does not change. The lambda never change. Okay. Those who just came in, please send your attendance. Okay, your attendance send. Okay, finish the diagram. Okay, question number 2. Which of the diagram show a bigger effect of diffraction? Explain your answer. How to answer this question? Very obvious that the diagram B is a bigger effect of diffraction. Explain your answer, but they want you to explain how to explain. How to explain this diffraction is a bigger effect. Anyone want to try answer? How to answer this? We know this is a bigger effect of diffraction but what is the reason? What is the reason of bigger diffraction of this? Okay, Leong Jianling. Leong Jianling, please come out. Leong?
Yes, sir.
Leong, can you tell me why? What is the reason of this one? The effect of diffraction is more effect bigger. Why?
Because it has smaller gap.
Yes, correct. Because the gap, another name of the gap we call aperture, because the aperture smaller than the lambda, or you say the wavelength lambda bigger than the gap, bigger than the aperture. Okay, okay, let's check the answer. Okay, I hope there's an answer here now. Here now, you see. So first diagram, second diagram. Okay, and then it showed that okay. The second part of the answer is saying diagram P will show bigger effect of diffraction. Okay, pay attention of this answer now. The narrower the gap, the more obvious the splitting of the wave. This answer because the narrow gap, the narrower the gap, the more obvious or bigger effect of the diffraction, of the splitting of the wave. The wave gets spread out. Okay, spread out. So, okay, got this answer Okay, everyone finish. Eileen finish or not? Did Eileen finish? Finish the answer?
Yes.
Good. Okay, Michelle finish or not? Michelle Chua.
Yes.
Finish, Eng, have you finished the answer? Eng?
Yes.
Finish. Okay, come. We look at the next. Next, you should be very familiar with this format already. This is 10 marks question. 10 marks that ask you to choose. Okay. Okay, now, not choose yet. They ask you to calculate something like that. Okay, look at this question. Diagram shows a guitar with 6 strings. The guitar produces a sound through vibration of a string, right? The sound of music note from guitar depends on the strings of the guitar. Each string has its own natural frequency. Okay, the string have their own natural frequency, because the thickness of the spring and the length of the springs are different, So every single spring will have different natural frequency lah. One is a thickness different. Another one is a stiffness. Some spring get tight, very tight. Some spring loose. It's different one, you know. All these are in the purpose of producing sound with different frequency. Okay. Now, table below show the characteristics of 4 types of string P, Q, R, S. Okay. Explain the suitability of characteristics of string to be used in a guitar that produce high pitch of sound. High pitch means the tones of the sound must be very high tone, high pitch, and will not break easily. The string must be lasting. Okay, the string not easy to break when it is strummed. Okay, determine the most suitable spring to be used and justify your answer. 10 marks. Okay, come. So there are 4 features. 1, 2, 3, 4. You are going to give your suggestion and also give your reason. Okay. Density, we start with density. How do you think the density of the string? It should be small density or high density, right? Nobody chose medium one. Either you choose small density or you choose high density. Okay. What is your opinion? The string or the guitar, the density should be high or should be low? How do you think? Okay, come, let's hear from you now. Michelle Chua. Okay, come, Michelle. Give your opinion, please. Michelle, the density of the string should be small or should be high density?
Small.
Small density. Yes, you make the right choice. Small density. Reason is what, Michelle? Why choose small density?
Lighter.
Yes, correct. It will be lighter, so the guitar will be lighter, easy to carry. That's the reason. So we choose the one with a small density. What about tension? Tension of the string. Low tension or high tension? Please give opinion. Ong Jiaxin. Ong Jiaxin, are you there? Jiaxin, Ong Jiaxin, where are you?
Yes, sir.
Ong Jiaxin, give your opinion. The tension of the string. You play guitar, isn't it, Jiaxin? The tension.
No.
You didn't play in your mind, or you have seen a guitar before, right, Jiaxin?
Yes.
So it should be high tension or low tension?
High tension.
Yes, correct. It should be high tension, very tight. Reason? Why must be high tension? Guess now, what is the reason, Jiaxin? When the string is very tense, tension very high. So what is the benefit?
Is it the sound?
Yeah, it's something to do with the sound, definitely. When the string is very tense, the sound, what is the effect to the sound?
Will be more clear.
Clear. Not only clear, no, you have a better terms. When the string is very tense, when you struck it, so what happened to the sound? Eng, can you help? Eng, when the tension is high, you can produce what types of sound? Eng?
Loud.
No, only loud.
I don't know.
Don't know so fast. Okay, your good friend, please help. Your good friend is Emily. Emily, are you there? Emily, or Emily cannot talk this morning. Emily, can you tell me when the string is tension, high tension, what is the advantage of that, Emily? Nicholas? Okay, Nicholas, please come out. Nicholas, where are you?
Yeah.
Nicholas?
Produce high pitch sound.
Yes, correct. It can produce higher pitch sound. Because it's very tense when you struck on it. The tone is very high tone. Okay, because the question said produce high pitch sound. So you need to be high tension. Okay, this one done. Okay, what about the length of the string? The length, you need it to be long or need it to be short? Either long or short, only you choose. Don't choose a number. Length of the string. You choose long or you choose short one. Vera, are you there? Vera Lim?
Yes, sir.
Vera, give your opinion, please. The string has to be long, the length has to be longer or should be shorter.
Short.
Yes, correct. Short. Reason is what? Why choose short one there, Vera?
I don't know.
Okay, never mind. Thank you. Okay, let's hear from Mu. Mu, please come up, Mu.
Yes.
Mu,
Yes.
why we need to choose the string shorter one? Mu, why?
Don't know.
You know. Okay lah, never mind. One more person. I try the last one. Lee. Lee, this Lee, please come out.
Yes.
Lee, can you tell me why we choose the string, the length shorter one? The length is short.
Don't know.
Also don't know. Nicole, okay, last person now. Nicole, please.
Yes,
Why the length of the string to be short?
the wavelength is short.
The wavelength is short now. Is correct lah, but I don't want this answer. You have a better answer when the string, the length is short. So what happened to the sound?
High frequency.
Yes, finally someone got it right. High frequency. When it is short, so you struck on it, it can produce high frequency sound, higher tone, higher pitch. Because the question keep on asking high pitch sound. So the string should be short. Okay. All right. Thank you, Nicole. And last one, the spring material. What material you want to use? Nylon, steel, which one? Choose the nylon one or we choose a steel? Which one? Caleb, please. Caleb, come out, please, Caleb. I know you are there, Caleb.
Steel.
Yes, steel. We choose a steel. Steel one is better. In fact, most guitar usually they use a steel string. What is the reason there, Caleb? Why you choose a steel?
Don't break easily.
Yes, correct. It is stronger, not easy to break, not easy to snap easily, correct? Not compared to nylon. Nylon will last long one. Okay, come. Now you answer in a table. Okay, take down the answer. Okay, it's like this. Your answer now. Okay, now you can see lah. First one, we choose low density. Reason, lighter. The guitar is lighter, easy to, less massive string. Wave travel faster. This one I think nothing to do lah. Frequency is higher now. Yes. Lower frequency, so you can vibrate faster lah. Higher frequency lah. High tension. Reason is high frequency lah. Higher pitch. Okay. Yeah. Smaller length of the string, the string should be shorter. The reason is produce higher frequency. Okay. And the last one, we choose steel. Okay. Steel, the reason is bright sound, clearer sound. We couldn't say bright, like clearer sound. The sound is very sharp, very clear. Okay. And high corrosion resistance. Steel, if you have higher resistance to corrosive corrosion, then it's lasting, does not break easily. Okay, same reason. Okay, please take down the answer. So like this or this, 2, 4, 6, 8, you get 8 marks already. Finally, you state your choice. So which one you choose and repeat the reason for the last 2 marks. Okay. Yeah. Okay, finish, huh? And the last one is, you have to state clearly now which one you choose. Okay, come, let's see the answer. So we choose Q. Q, Q is chosen. The reason is it has low density. You have to repeat, low density, high tension, smaller length, and also made of steel. The last reason. So the last 2 marks come from here. Okay, state it correctly which one you choose and repeat the reason. Okay, remember now the format, how to answer the question. Okay. Okay, finish now. We finish this question. Okay, come, we move to the next question. Not done yet, sorry, calculation. Last part, calculation. A certain microwave have wavelength. This is a wavelength. The speed of electromagnetic wave is equal to the speed of light, 3 times 10 power 8. This is speed of microwave or speed of electromagnetic wave. Calculate the frequency. First question, find frequency. So what formula now? You are given the wavelength lambda, given the speed, how to find frequency. What is the formula to find the frequency? What formula? Ho-Wan Yin, what formula? Ho-Wan Yin.
Frequency equal to speed over wavelength.
Yes, correct. Because the original formula is V equal to F lambda. Yes. This is a formula. Okay. So to find the frequency, you take the speed over lambda. Okay, thank you. Okay, this one finished. You calculate yourself. Number 2, when this wave enter a beaker of water, when a wave go inside a beaker, right? State what will happen to the frequency, wavelength, and the speed of the wave. This question is a good question. When the wave go inside a beaker, the beaker now the space is smaller space. So what will happen to the frequency and the wavelength and the speed when they go inside a beaker? The beaker, the space is limited already. So meaning that the vibration distance becomes shorter. So what happened now? Okay, check the answer faster for you all. Okay, first, you get this answer now. Speed divided by wavelength, you get this. Okay. And the second part, you see what happened? When the wave go inside a beaker, frequency will remain the same. Frequency never change one, okay? No matter what condition, the frequency will not change. But the wavelength becomes smaller, okay? And the speed also becomes slower. Three things here. Frequency never change. Lambda decreases, speed decreases. When it go into a bigger, smaller space, it moves slower. Okay. Using the formula V equal to F lambda, you can explain now. Okay. Because when it go inside the smaller space, right, the speed sure becomes slower. Okay. When this one slower, frequency never change. Frequency cannot change one. Okay. Then the lambda also must become smaller. Okay, they are related, directly proportional. Okay. Yeah. Remember this or not? Remember the answer. When you go into a smaller space, this will happen. Speed decreases. Lambda decreases. Frequency unchanged. Okay. All right. Next question. Question number 2. Okay, come study the question. What is meant by wave? Wave is what? When you study this chapter, first paragraph in your topic or in the paper is mentioned already. What is the meaning of wave? Wave is what? Wave is a type of energy, actually, it's a energy, right? You carry the energy or transfer the energy from one place to another place. So that is called wave. Okay, check answer. Wave is a periodic motion to transfer energy from one center of vibration from one place to another place. This is the meaning. Meaning of wave. Periodic motion. Periodic motion means the motion is in a certain rhythm. Okay. To transfer energy from one center of vibration, to transfer the energy from one place to another place. Okay. Okay, second question, ask about what? During high tide, so the sea water got high tide, low tide one, isn't it? Okay. High tide means the water come into the land very high, water very deep. Low tide means the water go away. A boat which stuck behind retaining wall, rocking up and down more vigorously. Explain the statement. What is the meaning of this? The meaning is like this, This is a water wave, right? There's a boat now. You say there's a boat here. Okay, the boat is here. This is a boat, Okay. I'm not very good in drawing now. Okay, the boat is here. Okay, you say high tide. High tide means a lot of seawater come in. Seawater come in now. Okay. So you notice that the boat is going up and down vigorously. Vigorously means it move faster, up. The boat move up and down very fast. Why then? Can you explain why? Why when the water come in during high tide, the boat move up and down vigorously? What is the reason? Definitely something to do with the wave, isn't it? Okay. During high tide, what happened to the water? Okay, check answer. Answer is here. When the depth increases, why depth increases? Because during high tide, more water come in, so the depth increases. More water, so depth increases. Velocity will increase. Remember that. Okay. In a deeper water, water move faster, right? Not, and wavelength also become bigger. Okay. When the water increases, the depth increases, velocity getting higher, and when velocity getting higher, the wavelength of the water wave become bigger and higher diffraction happen. Higher diffraction happen. What is the meaning of that? Okay, it's because of this, Usually, the place where you keep the boats, you have a wall behind. You build a wall, Okay, there's wall you build here. Okay, so you build a wall along the place to keep your boat. So your boat is here. This is your boat. Okay, so the water is coming in here. Okay, so the water come in Oops, sorry. Can you all see or not? So this is a wall. They build a wall, so you park your boat here, so the waterway come in. What is the purpose of having the wall here? Okay, this wall purpose is to reduce the wave energy. When the wave come in, we don't want the energy to be so high. Because it will damage a lot of things, when the wave come in. So they build a wall along here, but it doesn't block everything. It leave for some gap here so that the water will diffract. Okay? Because we know that after diffraction, the amplitude decreases. Amplitude decreases means the wave will have lesser energy. So not that harmful anymore after the diffraction. So bigger lambda, easy to diffract, right? Not? That's the reason. So remember the 4 points. During high tide, water becomes deeper, water move faster, the wavelength bigger, then diffraction easy to happen. Memang we want the diffraction to happen because diffractions can reduce the energy of the wave so that it won't bring so much damages lah. Okay, understand lah? Understand what I say or not? Lee, do you understand what I say? Lee,
Yes.
Sean, recall,
Yes.
understand or not? Recall.
Yes.
Okay. What about this? Kai Ling, do you understand what I say? Kai Ling Yao,
Yes, sir.
understand now? Janani, understand? Janani, can you hear me? Yes, okay, thank you. Okay, good to see you here, Janani. Okay, come. Next question. 10 marks. Again, they ask you to choose. A medical technician is using echo, to take pictures lah. Echo imaging this is called MRI, something like this lah, or ultrasound scanning, these are things using echo imaging to take photograph of patient who is suffering from liver problem. Okay, want to take pictures of internal organ. The quality of photograph is depending on the properties of the wave. Papers show 5 types of wave lah. You ask to choose. Okay, remember this technique is use a wave to take pictures of internal organs. So how this thing happen there? Because you see like this lah. The wave must be able to penetrate our body, go inside our body, go inside your liver, go inside your heart, your stomach, and then the wave when hit the bones, hit the tissue, it must be able to reflect. The sound get reflected. So once the sound get reflected back, right, there's a machine to detect the reflected sound. So every single time when the sound reflected, it will be recorded as a pixel, as a dot. Okay, one dot, one dot, one dot like that. So the whole organs, let's say the liver, the whole liver will reflect the sound differently. So it will form many dot on the screen. Finally, it will form the image of the liver. So by using reflection of the sound, okay? So now, types of wave. What types of wave we choose? You think of one. X-ray, infrasonic. I don't know what is infrasonic. Ultrasonic. Okay, which one to choose? Which one to choose here? Zhong Jiayin. Choose X-ray or choose infrasonic or ultrasonic? Zhong Jiayin, please.
Ultra.
Yes, correct. We choose ultrasonic. It's too dangerous to use X-ray. No, don't use X-ray. Ultrasonic, we choose ultrasonic. Ultrasonic, so you have here and here already. So now limited down to 2 only to choose. Okay, the next one, wavelength. Short or long wavelength. This one a bit difficult. We leave it first. The amplitude. Amplitude is something to do with the energy of the wave. So we choose high amplitude or low amplitude. Mock Trician, are you there?
Yes, sir.
Mock, you choose high amplitude or low amplitude one?
High.
Yes, high. We want the wave to carry more energy. High amplitude means more energy so that it can penetrate into our body. Okay, you need to have high energy wave. Okay. Okay, last one, the principal use. What principal use? Interference, reflection, refraction, diffraction. So which one? Because you also know one, which one we use. Okay, let's hear from Pan. Pan, can you answer? Pan, what principle use here? Pan? Pan cannot talk, so he typed. So let's see. He said, yes, reflection, correct. Pan, you are right. Thank you. Reflection. We choose reflection now. Okay? Because the sound hit the organ, get reflected. Okay? So very obvious already. So the answer is C, I think, right? Okay. C. Or we have another better one. What about diffraction, class? Diffraction can happen or not? But I think it's very obvious. It should be reflection now. The sound go inside, then reflect the principal use. Okay lah. Come check the answer. Okay. Check the answer now. First one, we use ultrasonic. Reason, suitable to detect soft organ. And another reason, ultrasonic is high speed, high energy. Okay. You can jot it down. Ultrasonic sound has higher energy. Higher energy, higher penetrating power lah. Okay. Long wavelength. The wavelength, we choose a longer one, Longer wavelength means it can travel faster, high speed. Okay. It can travel faster when the lambda peak, so it can travel faster. Travel faster means immediately can go inside, can detect very fast. And also can increase the reflection. Lambda peak, high speed, so very fast reflection can happen. Next, higher amplitude, more energy okay, more energy And the last one is reflection. We choose reflection memang reflection the sound reflected. Different intensity of reflection to map out the shapes of the organ. Different parts might see different parts of the tissue can reflect the sound differently. So different intensity of reflection can map out the shape of the organ. This is a reason. Okay. Okay. So the one we choose is which one? I think no answer. Which one we choose? With all these criteria, which one to choose? Which one to choose then? How Hansi, which one to choose? Okay, I see the question now. You have all these answers we give already. So which one are you going to choose? Ultrasonic. How give answer already? I'll say C. Yes, correct. I think we choose a C lah. Ultrasonic. But here is short law. Okay lah, come. The answer stated is long wavelength. Yeah, that's why. But C here is short. Then how? How? Ultrasonic, high, we agree one. Reflection definitely is correct now. Okay. If we choose short wavelength, okay, now I see the reason now. If we choose a short wavelength, it means we want to avoid from diffraction. We don't want the sound when go inside our body because short wavelength very hard to have diffraction one. Diffraction easy to happen when the wavelength is long, correct not? So when the wavelength is short now, the problem of diffraction will not happen now. You can avoid from diffraction. We don't want the sound to be diffracted, When go inside our body, hit something like obstacle, hit the bones or what, it will diffract. When diffraction happen, you won't get accurate answer. So I think you change this answer to short. Sorry, the answer is wrong. Now we choose to short. Okay, short. So you change to short. Change to short. Short, and then we give a reason now. Short wavelength. The reason is avoid from diffraction. No diffraction will happen. No, when no diffraction can happen, means the sound will hit accurately to the organ and then get reflected. What we want is the sound hit the organ, reflect. You can diffract. You see the sound diffract. So diffract means I can avoid from the organ, avoid from the obstacle. So no reflection can happen. Okay. You see. I think logical should be like this lah. Wavelength short. The reason is no high speed. We say avoid from diffraction. You write the answer. I don't write here. Avoid diffraction and increase the reflection. Correct. When not diffracted, when no diffraction happen, means the sound cannot corner. Cannot corner go to other place. You will have to hit the organ, like liver, then get diffracted. Okay. I repeat again for this reason. Wavelength we choose short. The reason is prevent from diffraction. Prevent from diffraction and increase the reflection. Okay. Because lambda small, very difficult to diffract. Okay. Okay, so we have done this. Okay. Got all the answer or not? Ong Jia Yin, do you get the answer? Ong Jia Yin, get the answer or not?
Yes, yes.
Okay. Okay, next. D, calculation. Calculation, I want you all to think of it. Sorry, last part not finished yet. Now we have to choose C. Yes, C chosen. Write the answer. Because ultrasonic with high frequency amplitude can be reflected. Okay, and short wavelength you say ultrasonic higher wavelength, sorry, smaller wavelength, lower wavelength, shorter wavelength very hard to write lower wavelength, smaller wavelength, and higher amplitude. Okay. The last one, calculation. Okay. Diagram shows a result obtained from microwave used to detect the locations of two airplanes, okay, that are approaching the airport. The first airplane is 5 kilometers away from the airport. The second airplane is a bit behind the first. Okay. Transmitted pulse. Transmitted means first time send out the signal. Okay, you send out the signal first time, and then hit the aeroplane, and then the sound come back. First time detected, the sound come back. There's a signal here. First one is send out the wave to hit the aeroplane. First aeroplane reflect the sound come back. So detected here. Then hit another aeroplane further. Second time the wave come back. So understand the signal. Here first time send out the signal. Hit aeroplane, come back, detected first time, first aeroplane. Then take a longer time, the second aeroplane reflect the sound come back. So meaning that this is start. This is a first aeroplane, the sound come back. This is a second aeroplane, the sound come back. Okay, understand the signal. Okay, now, with all the information given here, velocity, find the time represented by 1 cm. 1 cm. So how to find it? What is the time for 1 cm? Diagram show the result obtained microwave use. Velocity given this one. And velocity is given, and this is the speed. You have the speed, you have the distance. So how to find the time? Okay, come. 1/3 times this. Why 1/3 there, class? Why is 1/3 times 10 to the power of 4? Any other additional information given? Oh, yes. Now it's here. The first aeroplane is 5 kilometers away from the airport. It's given already. So meaning that this is a distance now. Okay, 5 kilometers away from the airport. So you have the distance already. And the sound here now is 5 cm more. 5 cm means is go and come back, means 10 kilometers already, you know. Okay. So to find the time for 1 cm, here 5 cm. 5 cm show actually that 5 cm is show that the distance traveled by the sound 2 times, you know. Hit go to the aeroplane and then come back. So meaning that 5 cm is equal to 10 kilometer, correct? Not 10 kilometer, go and come back 10 kilometer, right? Then you can find the formula now. What is the formula? You use T equal to Vt divided by 2, okay? Vt divided by 2. So distance, you put here 10 kilometer or change to meter lah. The speed using this one, and then you find the time, okay? Then divided by 5 cm. Okay, can you calculate? Put the distance. Distance you have to put 5, still 5 because times 2 here. The 2 is already here. So here you put 5,000. 5,000. Here put the speed is here. And then find the time. What is the time? You calculate now, I cannot write here, no. Once you know the time is for 5 cm, or then you can calculate for 1 cm lah. What is the time? Can someone calculate, please? Okay. Yeah. Okay, I have the answer here. I don't know whether you all can see or not. Can you all see? See lah. Okay, never mind. Okay, class. For this part of question later on, I will write the answer on a piece of paper. On a piece of paper, I will take a picture, send into the WhatsApp group. Okay. Okay. So this one KIV, I will do on the paper, then take the picture, send into the group. Okay, come, we move to the next. Next means we finish already. Okay, we still have a little bit time now, mind. I stop sharing. I ask question now, just like some quiz, Okay, come, get ready, So I will ask a question. Then when I call your name, so you answer, Try to answer, Don't worry, Okay, first questions, okay, class. What is the meaning of inertia? My question, I repeat again. What is inertia? Can you type the answer, everyone? What is inertia? Inertia is what? What is inertia? Emily? Emily, come out, please. Emily? Emily, where are you? What is inertia, Emily? Inertia is what, Emily? Can or not? If you cannot talk, you type it out. Inertia is what? What is inertia? Okay. I wait for answer from this Emily. Emily type already very long. Let's see what in Sid Eiling give the answer also. Inertia is a property of an object which resists a change in its motion. Very good answer, Sid Eiling. Sid Eiling, please put it everyone. Don't put private. Can or not? Emily, you put answer. Object resists a change in its motion. Also correct, but please change to everyone. Now you can see the answer. What is the meaning of inertia? Is when an object resists a change in its motion. Don't want to change, doesn't want to change. That kind of properties, okay? It's called inertia. You have two very good answers here. You can see, The second answer, inertia is a property of an object which resists a change in its motion. Okay, So very good answer. Thank you, Eileen, and thank you, Emily. You can see the answer there. Okay, my second question. Inertia is affected by what? Inertia affected by what? Meaning that the big or small the inertia is depends on what? Very simple. Inertia depends on what? Inertia depends on what? Lakshmi Chong. Inertia depends on what?
The size of the object.
Size of object. Half correct only. Half correct. Inertia depends on what? Anyone who can give answer, please type. If you don't want to talk, so you type the answer. Inertia depends on. Kim Yan Ming. Someone give the answer already. Two of them give the answer already. Yes, correct. Vignesh, Janish. Inertia depends on the mass. Yes, correct. Depends on the mass. Okay. Yes, correct. Inertia depends on the mass. So how How inertia depends on the mass? What is the relation between mass and inertial? Jacqueline. We know that inertia depends on the mass lah, but how it depends? Jacqueline Jacqueline knows how. Lim Sing-yin, can you answer how the mass affecting the inertial?
The smaller the mass, the smaller the inertia.
Yes, correct. Very good answer. The smaller the mass, the smaller the inertia. On the other hand, means the bigger the mass, the bigger the inertia lah. Okay, all right, this one finished. Okay, next one I will ask next question. Next question is what is momentum? What is momentum? Momentum is what? What is momentum? Joy Lim. What is momentum? Joy Lim, don't hide yourself lah. Come out, please. Joy, what is momentum? No sound. Mu Zhi Xiang. What is momentum? Mu, what is momentum? Magnus, give the answer. Yes, correct. Magnus, product of mass and velocity. Magnus, put it everyone. Please don't send private. For everyone, your answer is correct. Let everyone see. It's a product of mass and velocity. Okay. MV lah. Momentum is MV, right? Product of mass and velocity. Okay, thank you, Minich. Okay, next question. I want to ask this. What is impulse? Impulse is what? What is impulse? Yeah, I type my question here now. What is impulse? So your answer. What is impulse? This is my question. What is impulse? Answer, please. The change in momentum. Okay, very good. Okay. Change in momentum. Correct. So meaning that impulse is change in momentum lah. Okay, my next question what is impulsive force? What is impulsive force? What is impulsive force? Amanda, okay, you have been very quiet this morning. Amanda, please come out.
Rate change of momentum.
Can you type the answer? Yes, what you say is correct. Rate of change of momentum. Okay, impulsive force is rate of change of momentum. Okay, yes, thank you very much, Amanda. Rate of change of momentum. Okay, last question. One last question, okay lah. What is interference? Maybe I should ask this lah. What is constructive interference? What is constructive interference? Okay, read the question. What is constructive interference? And one more question. What is destructive interference? I have two questions here. What is constructive interference and what is destructive interference? Okay, please answer. Two questions there now. What is constructive? What is destructive interference? Anyone knows the answer? Okay, before I call anyone name, so you type the answer lah. Okay. What is constructive interference? What is destructive interference? No answer yet. What is constructive? What is destructive interference? Okay, Wang Yuhan. Wang Yuhan, please come out. Wang Yuhan. Wang Yuhan, hey, answer me lah, Wang Yuhan. Quiet, only this boy, Wang Yuhan. Wang Yuhan, okay, can you answer constructive interference? You see, someone already give the answer. Dennis answer na. Wang Yuhan, you answer constructive. This Dennis answer is say two waves superimpose to form a resultant wave with higher amplitude. Higher amplitude. Dennis, this one is for constructive or for destructive? Your answer is for destructive or constructive? Yes, you see, Sid Eiling say constructive interference occur when a crest or a trough of both waves coincide to produce a wave with maximum amplitude. Yes, Sid Eiling, make it for everyone. Very good answer, Sid Eiling. Constructive means the crest or trough of both waves coincide to produce a maximum amplitude. That is constructive. Constructive means crest and crest collide, or trough and trough collide. Okay, crest and crest collide, or trough and trough collide. They will produce a bigger wave, isn't it? That is called constructive. Okay, Sid Eiling, very good. Thank you. Okay, one last answer, please. Someone answer lah. Destructive is what? What is destructive interference? Ping Hao, Ping Hao very quiet this morning. Ping Hao, can you answer destructive interference?
When a crest and a trough from both waves coincide with each other and produce a wave with zero amplitude.
Yes, very good answer, Ping Hao. Ping Hao, can you mention again your answer slowly, one by one? Let everybody listen.
Occurs when a trough and a crest from both waves coincide with each other and produce a wave with zero amplitude.
Yes, correct. Means destructive interference means a crest and a trough coincide. Means one crest, one trough coincide. They cancel out each other to produce a wave with zero amplitude. No more amplitude, zero. Okay, Okay, with that, I think I want to finish here. Okay, for size 1. Okay, thank you very much for how many weeks already we have our online lesson until now. This is the last lesson already. Okay, so you go for your holiday for 1 month, enjoy your holiday, but don't forget, don't travel too much, okay? Remember, during your school holiday, try not to travel so much because it's still not so safe to travel, okay? And do remember, study a little bit, okay? It may be an exam, when school reopen, okay? We just need to wait for the instruction from the Japatan. If the Japatan says suddenly Form 4 final exam happen next year, so you have to sit for your exam, okay? So enjoy your holiday and please take good care, everyone. For size 1 and for size 3, okay? See you again. Bye-bye. Bye-bye, everyone.
Thank you, sir.
Yeah,
Thank you,
okay.
sir.
Bye-bye. Bye-bye.
Thank you,
Okay.
sir.
Thank you,
Bye-bye.
sir.
Thank you, sir.
Thank you, sir.
Bye-bye.
Thank you, sir.
Bye-bye.
Thank you, sir.
Bye-bye.